Okay, let's start. Um, Hi, Jabin, Ashutosh, and Yoshika. Can I please have a quick uh, introduction of yours so that I can ask a couple of things? We wanted to know from which background are you and what are you expecting out from this course? Mm, I would expect answers so that I can have a discussion session there and only in complete session. Anyways, we are going to discuss about the data and types of data, how data is categorized, and how is it being stored, how can a data be utilized. We get into that sort of discussion today. So the data is basically segregated into two categories. The very first one is the highly confidential data. This is customer related data, or so if you are an organization, you will have different types of data. That is your stake information, your company shares information, you have your customer information for holding your shares, or you have these sort of information. So it are very confidential and or your sales data, your product sales data, and also these are very highly confidential, right? So you have the client's payment to your companies, and also you get payment details of clients and that data. That is very highly sensitive and very highly confidential. So you categorize that data so that cannot be shared with anybody else, right? So next one is some sort of internal information which is confidential or confidential to only few people. That is, only few people can see it, like your ratings in the organizations, your private ratings and all, so which can more or less be seen by HR, but no other manager can view it, right? So that is another data that can be segregated into. And there is some other data which is internal to organization but not to anybody else. So that is only to the company. Like you have company details or uh, company internal meeting notes and uh, organization structures and all. So it is only seen by the employees, but no other public can see. There is another category that you can segregate the data to, that is can be disclosed to anybody across the world. So you can more or less segregate the data into four categories. Right? We will be more or less dealing with the category one with I mean, we have, if it all given access to every category, we'll be dealing with every category. But we are more interested in category one, as we can obtain the data easily without any constraints in between. So that is the basic understanding. So whenever we are trying to pull the data, so we can go to category one and pull out the data without any constraints. So if you wanted to pull the data of 3, 4, or 2, so we will need to get approvals and all, and then at least have a understanding with the company or MOU signed between the company to pull out the data, right? So that is how it is going to be. So next, coming to this is on to the higher level of organization level categorization. Now we go to the types of data. What exactly uh, data? What types of data we have? We more or less can segregate the data into two types. One is qualitative and the other one is quantitative. So let's first finish the qualitative. So qualitative data is something that we can more or less give the quality of the data, like what is the color. Let's say if at all you want to describe a person, you describe the person with the quality. So what are the good qualities of a person? So in that aspect, you also qualitative the data, right? So we can more or less segregate the qualitative data into multiple categories, like binomial data, nominal data, ordinal data, interval, ratio. So these are different categories in the qualitative data. So the binary data or binomial data is nothing but data can be segregated into 0 or 1, more or less. You have binary or binomial is 0 or 1. That is, you can put your data into either 0 or 1, which is true or false, which is good or bad. So you can right or wrong. You can come into this sort of conclusions, right? So when coming to nominal data, you will segregate your data into different categories, as in, let's say you are taking these candies below. So you can segregate these candies with the color: yellow, orange, purple, green, pink, right? So you'll more or less label them. So under yellow you have two, under purple you have two, under orange you have two. So you'll more or less segregate them, right? So the next one is ordinal data. Ordinal is kind of like an ordered structured order. You can more or less call it as a structured ones, right? So whenever you are uh, mentioning the height of the person, you can either put it as a short, tall, medium, right? Whenever you are describing the color of a person, is gray, black, or other complexions, right? So this is more or less a structured ones or ordered, right? The interval data is something like you can put everything only in the form of an integer. That is, interval data is measured along a scale in which each position is equidistant from each other. So you can measure the temperature or weight of a person and all, right? So that is more or less, let's say if you are measuring the weight of a class, class 10 students, you can more or less say the class weight ranges between this particular weight of 30 to 50, right? You have an interval. So all the students fit in between 30 kgs and 50 kgs. So this is how you describe. This is an interval, right? So then comes a ratio. The ratio is like you more or less compare two persons or two entities. You say one person is twice the weight of the other. One person is twice the height of the other person, right? So this is how you describe a ratio. Then comes a quantitative data. Quantitative data is something which can be uh, uh, shown or displayed in numbers, to be precise. So we can describe or segregate that into two other levels, that is continuous and discrete data, right? So my continuous data is something that can be divided and reduced to final levels, right? So that is, you will talk to the minute point of the quantity. That is, let's say if you're talking about the weight of a person, you'll precisely say my weight is 68.5, right? So we can continuously say this is what we can go to the points and say the weight of the person. That is what it says your continuous data. Discrete data is, let's say if you're saying number of people in your house, you cannot say 2.3 persons. You say 2 persons, 3 persons, right? So you will need to put it in a whole number rather than an integer. So continuous data, it can be placed in an integer. Discrete data, it cannot be placed in an integer. That is a simple thumb rule for it, right? So now so far we have known the basic data categorizations, the types of data, right? So going with the broad view of nominal, ordinal, interval, and ratio, this is what we can obtain from a data. Order is known in ordinal. In an ordered data, we will know the order and we will have the interval because your data is already in order between two ranges, and ratio also more or less gives the same. Counts, yes, you will obviously know in every data. You can find out when you have counts, you can find modes, right? You can find a median for ordered data. You cannot find a median for nominal data. That's because you are labeling more or less, right? So you can quantify the difference between values in interval and ratio, and you can of course do this in quantitative. That is, these doesn't fit for quantitative because anyways quantitative data will have all these properties. So this is, we are more or less concentrating about the qualitative, right? So now we know that we can find or have the data in any of these formats. How can we collect the data or how can we get the data? So let's say you wanted to do a review, or you wanted to have an appraisal with your manager, then you would have a set of questionnaires or a set of questions from both the parties that you will jot down and then upload into a portal, which can be normalized by the HR. So that's what it happens in general, right? So when you're talking about the category 2, you will have questionnaires and questionnaires. And then let's say if you wanted to find out uh, how is your company doing in terms of work-life balance for the employees and all. So you would conduct an internal survey and put some questionnaires to the employees and then gather the information and filter out how your company is doing in terms of GPTW, Great Place to Work surveys, right? So that is how you deal with the internal data. So if at all you are doing on a, if at all you wanted to gather the insights of a politician, you would more or less do a personal interview with the politician and find out what are his ideas and what are his ideologies, what are his party ideologies and all. So you can gather the multiple opinions and opinions from multiple personalities in the parties and then get a streamlined ideas uh, of the parties, multiple parties, one party first, and then do the similar kind of interviews with the multiple parties in person, and then gather all that information and speculate how is it going to impact the public or affect the public, and then uh, do a prediction which party is going to win the elections, right? So this is the reverse engineering kind of thing. So you'll not directly do it in public. So you'll do it from the party perspective rather than do it from the public perspective, right? So the next one is observation. Observation is something like, let's say, if you wanted to find out the number of vehicles that are traveling in one particular route. So you employ few people across the traffic junctions, and people would more or less uh, count with the ticker saying how many vehicles are traveling. This is very a vague mode of gathering the details or collecting the data, but this becomes effective when you have no other option left. So you'll more or less not have any option rather than counting the number of vehicles traveling through that route, right? So that is one. And focus group is, let's say, you have a group of students and you wanted to have a parent teacher meeting. So the group is not vast. So let's say in the previous, while we are doing the observations, that can be done on the public. When we are doing the focus group or collecting the data from the focus group, it is restricted to one particular group, and you are pulling out the details from that group only. So when you're talking about the schools, when you're talking or gathering the information about the schools, you will only look at uh, the list of schools that are there in that particular state or country and then pull out the data from only the schools, right? So we are focusing on the schools only. So we don't look out for any other data, right? So ethnography, oral history, and case studies are something that you look from the history and to be precise, if at all you wanted to find out about a medical case and pull out the data pull out the data of that medical condition and then do some analysis on it. So what you could do is you would pick up the cases or case history for that particular medical scenario and then do it, right? Your documents and records is more or less doing or collecting the data from different types of documents, records. So let's say if you wanted to find out the number of employees in a government, right? It is no way segregated in between. So what you would do is you more or less collect all that information from different sectors of the government and then uh, store it, and analyze it. Right? So I'll give you a minute and let me know if you have any queries in between. Right? I'm taking it as you don't have any queries on this, and then I'm moving it further. So we have data being segregated. We know how to or where to collect it from. So we'll know what are the sources of data generation, right? You'll have web services as a top priority one where you more or less generate the data. They there are again flat files like your logs and everything. So there are databases that where we can store the data. We have RSS feeds coming in, and we have many devices like mobiles, your uh, medical machines where you get all that health details and health sensor information, right? So we have data being generated everywhere across the world. Name a device, some or the other way, the data will be generated through that device. You're calling to one person from your mobile, it's a data that is being recorded in your uh, network provider, right? So name any device, it will generate the data, right? So that is where your IoT uh, researches are being going on, where you can club or um, club the data from multiple devices and find out what can we do with it, right? Let's say you're clubbing out the data of your mobile, your laptop, and your landline, so you'll know who is calling you on your landline through your laptop. So you can get this sort of information. Sitting at your office, you can actually find out who is calling on your landline at home. You can get this sort of information. So you can actually, you don't need to log into the landline provider and find out who is calling you. Instead of that, you can directly connect your landline device to your laptop and then figure out who is actually calling you. Makes sense, right? So you can, this sort of IoT researches are actually being going on. So the next one is you have your data being segregated. So you'll know, like, you'll have many issues while collecting the data or while segregating the data, while inputting the data, right? Major ones would be these ones, right? So for any new guy to the data, he'll need to know, he'll need to gather the appropriate data of the customer and then store it, right? You'll not, you cannot segregate one data or one customer data into another database. Like uh, a, a, a guy who only buys an umbrella every time, so you cannot store that customer into a hotel, or a guy who actually goes to restaurant daily. So you cannot segregate them into two different entities. That is what I'm trying to convey, right? So the data needs to be inputted properly, which is or which will be uh, missed more of time when it is done manually. right? The big data is that I've mentioned earlier, like we have the four V's that comes into picture, where you will more or less be con- concerned with the velocity of the data, with the variety of the data, with the volume of the data, with the veracity of the data, right? So then incomplete data is a big concern for the data quality, where you'll not have enough information or the complete information that uh, which is not no use for you. So it just fills your space, but it doesn't help you in any way, right? So we'll need to either completely fill in the data, or we'll need to erase the data, right? So compliance issue is you will need to, as I mentioned, you need to segregate the data or restrict the data to only few people rather than it is close to everybody, right? So with compliance issue is something which is concerning the world, across the world, in every organization. That's because your data is confidential to you. It need not be or it should not be disclosed to anyone else, which could be misused for any reason. Like your Facebook data is being breached, and your other data is being, you have much concerns on the Aadhaar number data that is used in India. Like your SSN is very secured in US, so your like your SSN, you wanted it to be confidential and it shouldn't be disclosed to anybody. Data purging and storing is, you have the very huge data coming in, right? You cannot store the data, and like you cannot increase on your database size every now and then, and uh, you cannot store it. So you need to purge your data. You need to know what data needs to be purged and what data needs to be placed on the database. So this you can more or less see in the financial sector, where you have data or trading information piling up in the database, and then you will need to understand what data needs to be purged, what data needs to be archived, what data needs to be stored for the live usage, right? So this is one of the major area where people are more working on data retention. The other one would be reconciling the data. You have your data moved from live database to a warehouse, and you wanted to find out the, find out if you have the data movement 100% accurate. How do you do that? So this is one of the major area that is, so if you are using any particular tool, yes, that works appropriately, but when you are doing it manually, you, how would you need to come to a conclusion saying you are reconciling the data appropriately, right? Sorry. Okay. So for all these data quality issues, we will need to build a proper data architecture which erases all these, or which clears all these issues, right? Which solves all these issues and put a proper data format that we can use it to analyze, speculate, or do some sort of analysis on the data and increase your company's revenue. Right? At the end of the day, what we wanted to do is we will always need to increase the company revenue and do it in a very minimal, uh, very minimal expenditure way, right? So data architecture is something that you build your set of rules, your set of standard policies and models and everything that you would more or less uh, define the way of data that is coming into your organization and go out of your organization, and what happens in between coming and going out is what you define your architecture. Like you wanted your data to be coming in a proper way. Though you get your data in multiple formats, like you have many formats across the world. Now it has been standardized to the XML format, but before to that we have flat format, and of specific messaging formats that actually come in. So you send it back, send the data back with some other format. Let's say if you're in a financial firm, you'll know the Swift formats or the Crust formats and all. So you get the data in, right? So once you get the data in, you more or less do all the set of processings and all, right? So once you do the processing, you will you get the data in one format and you send out the data in another format. Like in you send the Swift messages out after all the processing of the data, right? So you get the data in XML format, you send out the data in the Swift format. So there is some processing happening in between where you convert your XML, enrich more data, more values, and then process the data, and then create a Swift message and then send it across, right? So there should be some standard architecture which says what needs to be done at what stage. Right, once the data comes in, after the data is in, we need to modulate the data or enrich the data with some other values and all, and then pull out a few more information, and then uh, formalize the data in a Swift format, convert the data practically into a Swift format, and then uh, send the data out, send the Swift message out, right? So you have different stages in between where that needs to have a proper policy, compliance, efficient, right? So your data model should be built appropriate so that no intruder comes in and tampers that message, because that is very highly confidential. So you shouldn't give any scope to intruder to tamper your Swift message or prior to that as well. So once the data is out, it is not up to you, so it is up to your organization, or up to not up to your organization. So it is the responsibility of the Swift, so they would maintain the compliance that they whenever you are sending the data. So when the data is received and until the data is sent out from your organization, it is your responsibility to maintain the data integrity and data confidentiality, right? Not fall into that not to fall into that compliance and legal issues, uh, which actually kills your time and kills your money at later point if something goes wrong. So we should maintain a proper data architecture to maintain our uh, to maintain the data integrity and data confidentiality, right? So we'll have multiple levels of. So this is on a data architecture is on a higher level now. Yeah, whenever we are breaking it, we'll break it into multiple chunks. Like we'll have business models, we'll have system models, we'll have technological models, we'll have uh, hierarchy models, we'll have uh, we'll have multiple levels where you define your how is your data is how your data is going to come in. So let's say if you're talking about a business model, you have a product and you say your product will accept only XML formats, right? You or your client say he can feed in only uh, flag 34 format, right? So you'll have different formats across the world, and your business model comes in. It also deals with the client, more or less, right? So then your system model comes in where you, in my previous example, where you say your data can flow in multiple levels, right? You'll define the system flow, saying once the message or once the XML data comes in, it should go into this particular level, right? So it should be enriching all the data at stage 2. It should formulate the data at stage 3. It should convert the data at stage 4. So you'll define the system models. You'll define the logical aspect of the model, right? So then comes your physical or technological model saying what database needs to be used, at what level, and what technology needs to be used for pulling out the or gathering the XML data or inputting the XML data, and what database or what process or what stored procedures or what SQL language needs to be used to process all that data, or do we really need to use any other scripting language to process that data, or do we how do we convert that data? Do we really need to use any technical scenarios, right? So we build a technological model and then solve all these issues, right? So then comes the basic components of the uh, data architecture, right? Whenever you are building the models, the business model or the system model, technological model, you'll more or less need to concentrate on these components of the data architecture and then build the models. So whenever you are building a model, you should more or less be concerned on distributed processing. Instead of single processing, you will need to uh, split your data or put your data in distributed databases and process it, right? So then you will need to look at the flexibility of the data where you can plug and play the servers, and you'll need to look at the volume of the data that comes in. Let's say in my previous scenario, what if you have 100 million XMLs coming in? Does your system accept that? Can your system process all that 1 million data in a given time frame? It doesn't make sense if your data actually if your system actually processes all that 100 million data in a day, whereas that trading information needs to be solved within next 1 hour, right? It doesn't make sense. So your system needs to be flexible and robust to solve all that or process all that messages within next minutes. So you should build a robust model to process it, right? So you should be more concerned about the compliance and data access. So like uh, whenever you are providing access to the users for your system, you'll segregate the access. You'll for a data entry guy, you'll not provide the access to the reports of any financial level, right? So you'll restrict the access for multiple teams. So let's say a tier 1 team cannot actually go onto the database and update it. That is segregated onto that is owned by the tier 2 or L2 guys, right? You should be having an ability or your model should handle different types of data. It is not only with the uh, XML format. Let's say if you are building a model, you should build a robust model to accept any type of data across the world, right? So if you are having a new client coming in and he says you are going to uh, feed in only textual data. You cannot feed in XML. He has only ability to feed in text data. So you cannot sit down and develop and waste your effort in building a new data format, a new engine to accept the textual format. So you have your engine to accept the XML data. Whenever you are building the engine to accept the XML data, you should be conscious enough to build whatever the data formats that are there across the world. You should be conscious enough to build an engine to accept all that data types, right? I hope this is clear. So whenever you are trying to build a database or develop a database, you need to be on the most conscious that your data should be very easy to access. So this comes with the ER diagram. So having the multiple foreign keys, having the multiple indexes on the data, or having no indexes on the data makes very hard to access it, right? So you'll need to have a proper database built so that you can do a query onto the database very easy, as simple as that. Right, building with the primary key and clustered indexes, you can easily solve the pulling of the data. Let's say if you're doing a multiple join query and it takes long time for 100-row data, so that really doesn't make any sense whenever you're handling the high volume data. So that really doesn't help you to pull out the details. So we will need to uh, put these things in our minds, or whenever we are actually building the model or building the data architecture of the organization, right? So the next one would be now we have data being stored across the databases. So we know where we get the data from, the source of the data generation. So we also know what is the data architecture and how the data flow goes, right? So then your OLTP or OLAP comes in. Anyone help me with the OLTP or OLAP abbreviations? Yes, no? Okay. OLTP is online transaction processing and OLAP is online analytical processing or analysis processing. So OLTP is more concentrated on the processing part rather than analysis part, right? In my previous example, let's say your XML message is coming in and you wanted to process that XML message. You wanted to enrich more data. Let's say you have 5 fields inputted with that. You wanted to populate more data with the inputted 5 fields. That is, you'll need to process your data or the XML given message and populate more messages with the help, more details with the help of five fields, right? So we are more looking for the processing of the data, right? And then store it onto the database. So in OLTP, we will be more or less using the any of the SQL queries like delete, insert, update, select, right? All that queries will more or less be used. So when you are storing onto the database, you store them, and then while OLAP is online analysis processing or analytic processing, where you more or less do the analysis part rather than the processing part, right? So while we are doing the analysis, we will need to know, or we will more or less do only use select queries rather than using. So we will not update anything on it. So once we move the data to the warehouse, we will more or less not have any update permissions on it, right? So once we move the data onto the warehouse, we can play around using the multiple models. So this is where your big data technologies come into picture. So now you have business process or business data being stored onto a database, right? So once you wanted to move that data onto a warehouse, it is hard to move the data from a live database onto a warehouse. That is where your ETL tools, your big data technologies come into picture, right? So once your data is into the warehouse, you can do whatever analysis on the data, like your data mining, your analytics, your decision making. So you can perform all these analysis on the warehouse, right? So this is the major segregation of the data that we can talk about, right? So once we have an idea of what the data is and what are the types of data, what are the types of data processing techniques, what can be a data model, what can be a data architecture. So how the data is going to be, play a major role, how the data is going to play a major role in our analysis. Because we more or less rely on the data for our analysis. So we should be major concerned about the data that we are actually looking for. So from where are we pulling that data? How the data can be validated? So we'll need to know all that information, right? So now that we have known what data is and how the data can be seen, or where can we get the data from, what are the sources of the data, so we know all this information. So now after this, we'll go with what are the tools that we can use. What are the tools that we can use in our data science, right? So let's uh, let's take on this tomorrow. So after tomorrow's class, from Monday, we will more or less be dealing with statistics. I will more concentrate on the tools that will be using in the data science and how it plays a major role. What are the best tools that we can use in, right? So we'll get into these tools level tomorrow. Any queries that you can pose for me as well. Ready to answer your question. Right? I don't think I'm getting any queries, so I'm done for the day. let's catch up tomorrow on the tools that we'll be using in the data science. Right? Have a nice day. Bye.